Hello friends, this is Durga again from ITversity. As part of CCA, Spark and Hadoop developer, at this time I am talking about joining disparate datasets together using Spark, which is part of transform stage and store module. And so far I have covered how to run the join. I have ran the script till here, and we have seen that for in copy paste dot take 5 print of I, and you can see that we are getting for each date, for each order, we are getting the order item subtotal. And to get the revenue for each day for all orders, we have to add these things, which we will do subsequently. And also, if you go back to our problem statement, we want to get the revenue and also number of orders on daily basis. So when we say number of orders, it is distinct order IDs from the order item from the order items table. We have to use order items only to get the orders or order IDs also, because we have one-to-one relationship between orders and order items, and there can be orders where there are no order items. For example, if the orders are cancelled, then there need not be order items. To validate that, you can run this eval command on first on order ID from orders, distinct order ID from orders. I don't know why it is killed. Anyway, closing it here, eval to minus vi eval, and I want to run count of distinct order ID from orders table. You can see there are 68,883 orders IDs in orders table, whereas if you try to get order item order ID from order items, which is nothing but the parent order ID in the order items table. There can be many order items for each order, and we are trying to get what all order IDs that make into order items, because there can be orders which can be cancelled or without any order items for some reason. Hence, if you run this query, you can see that there are only 57,431 orders in order items table. Others 1100 could be cancelled orders or something else. That being said, the main thing what I am trying to emphasize is to get the second item, which is number of orders on daily basis. We typically want the orders that are successful. And the reason is downstream we want to compute average revenue for all the successful orders. Hence, we don't need the orders that are not successful or that don't have order items. For that reason, we have to get order IDs only from order items. And then because we are trying to get from order items, there can be multiple rows for a given order ID. For example, when we fetch results from this copy for I in paste dot take of 100 print of I and hit enter, you can see that if you look at these three records, there are 3 order items for one order ID, which is 36, and we need to on whatever day this order is issued, we need to get only one record out of these 3. So we need to compute the distinct of order IDs for each day. So to get that, as we need the date component, we have to use the joined date. We have to use the orders join order items here like this, and then if you look into this order join order items, from this we need order ID and also order date from order items table. Okay, if you look at this, for in paste dot take 100 print of I and hit enter, we are getting 100 records, and this is the order ID and this is the order date. So we need to get this order date and this either this order ID or this order ID or this order ID. Any order ID we can get from the joint dataset. In this case, we will try to get the order date and the order ID. So again, this order date can be represented as if this is called as rec or record, then this will be rec of 0, this will be rec of 1, and this will be rec of 2. Sorry, this entire stuff will be rec of 1, which is again a tuple. To access this tuple, you can say rec of 1 of 0 to get the record from the order table, and rec of 1 of 1 to get the record from the order items table. And to get the second substring, which is delimited by comma, you have to say rec of 1 of 1 and split using comma, and then from that array you can get the first item. And then we have to concatenate the order ID itself to that using some delimiter, in which in this case we will be using comma for that. So it will look like this. I am saying orders per day, and the join variable is orders join order items. So paste, and we have to use map lambda rec, and the first thing we need to get is rec of 1, because this is rec of 1, and then from that we have to get 1, which is this one, and then we have to split by comma, and we have to get the which will return a list, and in that list or array, this will be the first item and this will be the second item, which can be represented by 1. And then because we want date as well as orders, distinct orders for each day, we have to say plus, we have to give some delimiter, and then again concatenate. Because this one is of type integer, we have to convert it into string, otherwise it will throw an error. I am saying string of, and it is represented as rec of 0, and then we have to close this one for the first bracket closed is for this one, and the second one is for this one. And then you will get duplicates, because if you see, this has 3 entries. Let's see that. Okay, we have to, I think, give one more bracket. Let me see. Yeah, one is for string, one is for this one, and the other one is for map. So I have to give 3 brackets here. Now it works. And then for in orders per day dot take 100 print of I, and hit enter. You can see that it is giving duplicates for each order on a particular day, because order items have the duplicate order IDs, because multiple order items are related to one order ID. So what we have to do is we can apply distinct on this and hit enter. And now if you see, for in orders per day take 100 print of I, you can see that there are no duplicates in this. So now we have all the distinct can be applied only on the keys. For that reason, we have included both order date and also order ID in the key itself, and then we have applied the distinct. Okay, if you want, you can actually remove the distinct, and then you can say orders per day count. You get 172,188, and with the distinct you get 57,431, which is equal to the number of orders, distinct orders in the table when we ran it on MySQL. Okay, that's how you can actually validate the data also. That being said, now we got the distinct orders also by using this one. Now again we have to split it into order date and the orders, so that we can join the revenue per order per day and total revenue per order per day and orders per day. So we have to join these two so that we can actually get order date and revenue and orders for each day. Okay, so now we got the distinct date and orders. I'm splitting that by applying a simple map function, by splitting the comma separated order date and order ID, and for each order date I am giving one for it. That is enough to get. I'm discarding order IDs after getting the distinct date and order ID, and for each order date and order ID combination, I'm getting order date itself and then getting one for each order, discarding order ID completely. Okay, so what I'm trying to do is let me copy paste this one. Paste. Now you can see that the previous orders per day, which have the combination of order date and order, I'm splitting the first. I'm splitting by comma delimiter and getting the order date first, and then assigning one to each of them. And now if I do for I in copy paste take 100 print of I, you can see that for each item I'm getting the order date and one. Now I can simply holding the order date as key, I can simply add all the ones to get total number of orders per day. Similarly, if you look at revenue per order per day, there can be multiple entries. Paste. Take of 100 print of I. You can see that there are multiple dates for which we have the multiple entries for the date for which we have the order item subtotal. So we have to add these things to get the number of amount of revenue that is generated. Okay, so if you look at revenue per order per day dot count, it is giving 172,198, and we have seen when we actually compute count on this item, it is giving 57,431. So finally we should have only 57,004, not even 57,431. We should have only the number of days we have in the dataset because we are trying to compute for each day. That being said, you can run this command using reduce by key on this variable, which is orders per day passed. For each order we are assigning 1 on each day, and hence we can actually run this command, paste. Here we are using reduce by key, and reduce by key is the aggregate function holding the key, and you have to pass two variables. One represents the current value and the other one is next value. Until it finds the last value, it will keep on adding, and it will be assigning the sum moving forward to one of the variables, and in the end it will get you the result for each key. It will get you the sum for each key. Okay, now you can actually say total orders per day dot count. So first we are actually seeing how many are there. There are 364. This data set is for 1 year, so it's approximately close to that. So it will eventually have 364 records. You can also do for I in total orders per day dot collect, print of I. Now you can see there are 365 dates, and then these are the number of orders for each day. Similarly, using the revenue per order per day, we can compute the total revenue also using this. This is also by using reduce by key, and here also we are using two variables which will be added on moving forward basis. So you can run this one and paste it, and you can do copy paste and then count on it. It returned 364 records. You can also do for I in and validate. I am not going to do that, but I have the script here. Now we have two data sets for which date is the key. One has the number of orders per day, and the other one is having the total revenue per day. Now we can join these two data sets and get revenue as well as total orders per day using another simple join that is represented here. It is called as final join RDD, wherein here, because both of them having equal number of records, you can use either way. You can it doesn't matter whether you have which RDD is in the join function, which RDD is the one outside the join function. It does the placement does not matter because both of them are returning the equal number of records. Okay, that being said, let's run this, and then you can actually validate the values, and now you can see that you get the date. You got the total number of orders for the date and then the revenue. And if you want to get it on sort basis, you can say sort by key dot, as we have only 364 records, I'm printing everything. Now it will be sorted by the key, which is date. Okay, I have to say collect. Now you can see that it is sorted. The final one is 2014 July 24, and you can see that it's actually sorted by going back until the first record, which is July 25th 2013. So that's how you can actually join the data and also run the aggregations. There are many other aggregations also which will be covered as part of the next item. Here I am just trying to show the value of join, and then how you can get the insights by leveraging the joins to implement more complex operations on the using Pyspark. That being said, now as you have the total number of orders for each day and also total revenue for each day, you can just iterate through them and get the average by just dividing the total revenue by the total number of orders for each day. And also it will be better to evaluate the results. You can evaluate easily if you are familiar with SQL. You can do that by using scoop eval command if you have access to MySQL database, and if the input is from MySQL, you can run a join query using MySQL and you can validate the results, and that will confirm that you are doing it right. That being said, so far we have covered how to join using plain Python-based Spark. In the subsequent videos, we will try to use SQL context as well as Hive context to perform the joins very easily. Here you can see that we have written almost 6, 7, 8, 9, 10, almost 15 lines of code to get the join, and there are so many things you need to remember. But if you are comfortable with SQL, there is much more elegant way of doing this. Most likely they will they might not worry about whether you are using plain Spark based Python commands, or whether you are using Hive context or SQL context within Pyspark. It might not matter for the certification. If it does not matter, I will highly recommend you to fall back on SQL and develop your code quickly than struggling with Python based Spark code unless you are completely comfortable with it. That being said, I hope you are enjoying the content on my channel. If you like this video, please click on the like button. If you want to provide the feedback, please use the comment section of the video. If you want to ask any technical questions on this, please use the Stack Overflow and tag it with appropriate tag words like Pyspark and Apache Spark. I will be closely monitoring those things and I will try to answer your questions. And also, if you want to discuss as part of the groups, I have the LinkedIn group with the name IT Varsity Hadoop certifications and also IT Varsity Apache Spark. We can discuss with respect to certifications of Spark on those groups. Please send the request to join. And if you have not subscribed to my channel yet, please do so. You will get to see a lot more content like this over time. Thank you. Bye.